is the 8.1 lesson for honors geometry. It's called Pythagorean Theorem and its converse. So we're going to go through a lot of this. Is going to look kind of familiar because we did a lot with Pythagorean Theorem first semester and kind of used it whenever we needed to find the distance until we learned about the distance formula. So now we're kind of just extending it because our new unit, Unit 8, deals with trigonometry, specifically kind of working with a lot of right triangles. So here's our first little reminder of what Pythagorean Theorem is. It says in a right triangle, because this only works in right triangles, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So I know it's kind of wordy, but the idea is just to say that if you take your hypotenuse and square it, so c squared, it's going to be equal to the sum where you add a squared and b squared. So you have to square each of the legs and add them together. So this right here, remember, is Pythagorean theorem. C squared equals a squared plus b squared, or you can write it the other way around. And so we have one new introduction of something that we haven't really talked about yet, but it's going to make your life a lot easier if you memorize what's about to come. It says a Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy this equation, the c squared equals a squared plus b squared. So it's basically that mathematicians were able to figure out that these specific numbers kept giving you the ratios that needed to be there for Pythagorean theorem. So every time you had, let's say, two legs that were a 3 and a 4, the hypotenuse always would equal 5 once you solved and found the hypotenuse. And then same thing for these next ones. Now the ones that are bolded are the ones that I would make sure you memorize between now and eventually the quiz, eventually the test, because it's going to make it so much easier. It saves you so much time when you see that a right triangle has two legs that are 3 and 4. Or if a right triangle had a 3 for a leg and 5 for a hypotenuse, you would know that the missing leg is 4. And you wouldn't have to show any work. That's kind of the nice part, that's what these triples allow you to do. So let's say you see an 8 and a 15 for the two legs of a right triangle, then you know the hypotenuse has to be 17. And it can work with any two of the three. So as long as you know two of them, the third one would have to be the case, so you could always find the missing one. Now you can still use Pythagorean theorem, but again, you're just saving time if you memorize what's in this little box. And so you would memorize the first 4 of these, like 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, and 25. Honestly, sometimes I forget about these last two, but these ones that come up often makes it so much easier. And just kind of quickly being able to memorize that makes your life a lot easier, because what it does then is you can do multiples of these. So on this one here, it multiplied 3 times 2 and got 6, 4 times 2 and got 8, 5 times 2 and got 10. And you can multiply it by anything. That's what this is showing us here in the third row, that you can do 3 times any number. As long as it's the same number that you multiply for all 3 terms, that would be another example of a Pythagorean triple. And so triple just means there's 3 numbers that we're working with, and they always will hold true with the Pythagorean theorem. Same thing here for 5, 12, and 13. So if 5 turned into 10, that means we multiplied by 2. The 12 would have to get multiplied by 2, and you'd get 24. And then same thing. 13 multiplied by 2 get 26. Or you can multiply by some other number, not just 2. On this row of this table, though, we multiplied everything by 2. So 8 times 2 is 16, 15 times 2 is 30, and then you get the 17 times 2 is 34. Then finally, 7 times 2 is 14, 24 times 2 is 48, and 25 times 2 is 50. So again, the third row just tells you that you can multiply by anything at all, but we just showed an example by multiplying by 2's in this second row. So it does say, note, the most common Pythagorean triples are in bold. That's the ones, again, we just went over. You don't have to memorize everything else, because that would be impossible. Again, I would just stick to these 4 Pythagorean triples. And once you know those, then it's just a matter of multiplying. It says other triples are a result of multiplying each integer in a bold-faced triple by the same factor. So you get to multiply by 2's or 3's or whatever. So if you notice in a right triangle that the numbers are all divisible by a common number, that means let's say they're all even, you could divide them all by 2 to see, does it end up with one of these Pythagorean triples, or you keep dividing by numbers until you get to a point where you can't find a common factor for them. But if that would take too long, then it might be easier just to use Pythagorean theorem. So remember, you can always use Pythagorean theorem even if it's one of these four. It's just this makes it easier. Okay, so we're going to try out two examples together of just kind of remembering how to do Pythagorean theorem. So one is in context, because if you look at the practice on the next page, there's a bunch of in-context problems that we're going to be practicing. Homework tonight will have some of that too. So a lot of this, again, though, is review. None of this is like brand new other than just looking out for those triples. Okay, so it says, Carrie made a ramp for her dog to get into her truck. The ramp is 6 feet long, and the bed of the truck is 3 feet above the ground. So we're going to draw this out. There's the ramp, a right angle here because it is a straight, like a horizontal and a vertical line that meet. So the ramp itself, it says, is 6 feet long. It would have to be like the hypotenuse part of it, because that's what the dog will kind of travel on top of. Now the truck, it says the bed of the truck is 3 feet above the ground. So that would be 3 feet here, because this is the ground, and then this is where the truck is. And the bottom, we don't know. It says to the nearest hundredths, approximately how far from the back of the truck does a ramp need to touch this ground? So from the ground all the way to where it gets to, the ramp ends here, or starts here, and then this is where the truck starts on the ground. Okay, so to figure this out, we can call it x, and here's where we would do Pythagorean theorem. 3 squared plus x squared equals 6 squared. That's 9. And you don't have to show all of your work, but I'm going to show it here just so that you can kind of follow along. And then we want to subtract the 9. So you would get 27. And now we're square rooting it. And remember, this is where simplified radical comes back again. Or in this case, it did tell us to round approximately to the nearest hundredths. So when you grab a calculator and round, this comes out to approximately 5.20. And the units are given in feet. So our final answer should be as well. If it's not a story problem, sometimes we'll keep things in simplified radical. But again, just follow the directions on any homework or on the quiz and the test eventually. And then for number 2, it's just a lot of finding the missing sides or angles. Well, in this case, it only wants me to find this side, which is x, and then this side, which is y. But in order to do that, we'll have to do Pythagorean theorem maybe multiple times. So the first one here is I see a 10 and an 8. As soon as I see those two, though, I might say, well, could this be a Pythagorean triple? Because maybe it's a 6, 8, 10. If you weren't sure, you could divide them all by 2 and see, like, this would be 5, that one would be a 4, and so, yep, this is a 3, 4, 5, but they've been multiplied by 2. So that's where you got 10, 8, and 6 from. So without doing any work, I can find out that x is 6. Now you can do Pythagorean theorem if you prefer to do that instead with x squared and 8 squared equals 10 squared, but just for making sure we use these patterns when we can, it'd be easier to not have to use this and instead use the fact that this was a Pythagorean triple. Now on your homework, on a quiz test, you don't have to mention it's a Pythagorean triple. You can just literally write the answer. And then once we know that this is 6, we're ready to find some of the other missing sides. So we have, in order to find this y, it's not part of any triangle, like it's not its own triangle. I need to work with kind of all this big triangle here. So we have 15 here. This side here would be 25, right? And so we're looking for all of this. I can call that z, because once I find it, I'll subtract 10 from that to get my final answer. So we could do z squared plus 15 squared equals 25 squared, because that's the hypotenuse, and solve for z. So we'd get z squared plus 225 equals 625. Once you subtract, we get 400, and then once you square root it, you get 20. And actually, this one was actually a 3, 4, 5 as well, and I didn't catch it. But you could have used 3, 4, 5, because if you divide each of those by 5, you get 3 and a 5 for the hypotenuse. So if this is a leg, then the next leg has to be 4, and you also multiply that by 5. So again, if you see the pattern, I didn't catch it right away. It was another Pythagorean triple. Without having to do any work, you could have gotten that z was 20, because you just do 4 and then multiply it by that same factor, which was 5, is what they were getting. But to get y, we know that if z is 10, z is 20 and this part is 10, that means y is just 10 as well. You don't have to show work for that, but you could say z is equal to 10 plus y, 20 is equal to 10 plus y, essentially, and solve that if you wanted to, but you don't have to show work. So on a problem like this, I showed still quite a bit of stuff. You could literally do all of this without any bit of work. All right, so that's kind of the idea for even on homework. Look out for those triples if you can find them. That makes it go much quicker. And then on the back here, you can try out as many of these. We'll go over some tomorrow too in class if there's questions, if you end up trying some. But at this time, you can either work on this back page or work on your 8.1 homework. And we'll go over both those things tomorrow. And that's about it.